All right, we've been using the distance formula and the slope formula. Now we're going to apply them. You'll see step by step how you can prove a square using these formulas. We all remember Timon's square. Everybody said that his square was really the best. Well, what really made it so good? Here's his square set on the coordinate plane. What do we know about squares? We know that all four sides are congruent, or they're the same length. We also know that consecutive sides are perpendicular, meaning they meet at a 90-degree angle. Consecutive sides are the sides that are next to each other. Perpendicular means they meet at this 90-degree angle. So how can we use these formulas to prove that Timon's shape really has everything that a square needs? To prove that all four sides are congruent, we can use the distance formula on all four sides. To prove that consecutive sides are perpendicular, we can use the slope formula, and we're looking for those negative reciprocal slopes. Here's the distance formula applied to all four sides. Write it like this in your notebook, taking note of the segments. So here's AB. Next, we've got BC. Here's side CD and side DA. Label your X1, Y1, and X2, Y2 points, and then plug them into the distance formula. We're taking the square root of the x's subtracted and squared plus the y's subtracted and squared. We're getting radical 10 for AB. For BC, we also get radical 10, being careful that this -3 squared is going to be a positive 9. For CD, we get the same thing. And for DA, also radical 10. So all four sides are radical 10, meaning they're all congruent. So we've proven that all four sides are congruent. We're halfway there. We also need to use the slope formula to prove that these consecutive sides are perpendicular, that all these corners really are 90-degree angles. So let's use the slope formula. We're choosing side AB and side BC as our consecutive sides. Label X1, Y1, X2, Y2 for both segments, and then just handle them one by one. First, we'll do AB, rise over run, subtracting the Y's on top, subtracting the X's on the bottom. We get 3 over 1. Think to yourself, what should the slope of BC be if we're looking for perpendicular lines, if we're looking for a 90-degree angle? It should be negative reciprocal, so we'll see a flip and a change of sign. And that's exactly what we get. Our numbers are flipped and we have a change of sign. It was positive and now it's negative. These are our negative reciprocal slopes. And it's exactly what you wanted. It's what we needed to prove that these consecutive sides are perpendicular. We've got everything that we need to prove that this is a square.